Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh, it's the Science Cafe with your host, Chris Smith.
All right. Hi, everybody. Good evening. Thanks for coming out to the Daily Planet Cafe tonight. My name is Chris. I am your host for the Science Cafe every Thursday night here at the museum. Yeah, that's right. Turn your chairs around. Get ready. We're about to do some pretty cool sciencey stuff here in the best museum cafe in the world, the Daily Planet Cafe. Thanks for you all for coming out tonight. Tonight we're going to celebrate the legacy of Apollo. Now, I don't know. I wasn't around when the Apollo program was ongoing. I have only seen the grainy stock footage of this happening, but as a young person, it was still one of the most inspiring things that I came across as a child interested in science, technology, engineering, mathematics, and look where it's got me now. I have this awesome job working in a science museum. But when I was young, space was my jam. Loved to read, learn. Once the internet came along, I am of an age, and I could watch videos about it, visit the NASA website. I spent every afternoon on the NASA website reading and learning as much as I could, and carried that through, that curiosity, I guess, through. And so it has, I guess, maybe just a little bit of a special significance for me for this to be the 50th anniversary, 2019, of the Apollo 11 moon landing. Y'all knew this was happening, right? If you didn't, there's a little pamphlet on each and every one of the tables here that'll tell you all about it. The North Carolina Museum of Natural Sciences, the Museum of History, Moorhead Planetarium, and a number of other science and cultural institutions all over the Triangle. We're all working together to talk about the 50th anniversary and celebrate it with everything from symphony concerts to astronomy days to events like tonight. So, to celebrate the legacy of Apollo and in this case, look a little bit forward into the future, we have a very special guest, professor of lunar geology, and it might be the only time I get to introduce somebody with a title like that, but a professor of lunar geology, Dr. Clive Neal is with us from the University of Notre Dame. Please put your hands together and welcome him to the stage.
Thanks very much. Thank you, everybody. So as you probably know from my northern Indiana accent, this is, I'm a little different, but I am wearing a tie tonight. It's a very special tie, celebrating, and socks. Got to get them in the gift shop right here. You can go get them. I mean, so I'm going to take some home with me. All right, so who wasn't alive when Apollo 11 landed on the moon? And don't lie to me. Really? Oh. Well, this is good. We got some people here who will be able to correct me when I mess up, because I was alive but living in a different country. And the question is, which country was I living in? Any? Who said Australia? Okay, you can leave now. It's anybody else? England. Yes. Yes, my father got me up at 4 in the morning to go watch history, and as a young boy, I didn't want to get up, but he got me up, and now I stand before you with a few little pieces of good luck to get me here. And I want to talk about Apollo because I've spent the last 3+ decades looking at the samples that they brought back. I've been working with NASA a little bit, and I'm very interested in the policy that is going on right now in getting us back to the moon to stay. Whether by 2024, I don't know, but we can talk about that later on. So in terms of Apollo, I want to show you just very 50,000-foot look at the gifts from Apollo. These are the samples that were brought back. They are the gift that keep on giving. And I'll illustrate that in a little bit. And you can see the launch dates next to each one of the Apollo missions with the different quantities of samples that were brought back by each one of those missions. And over there on the right, you can see that we have Luna 16-20-24. These are Soviet Union robotic sample returns, and these were much less, but still from a very different part of the moon. And we're finally, well, there was an exchange of some of those samples with NASA back in the 80s, and now we finally have an access through collaborations with Russian scientists to actually look at some more of those samples. But I'm a geologist. I can't go because I'm too fat, and so they're going to need a bigger rocket to send me. But I'd love to have some more rocks, please. Thank you very much. The young people that are here, you're going to be going, so take note. Take note. I need you to bring me some rocks back when you go to the moon as astronauts. No messing. So the other thing that the missions did is they set up the first seismic network off planet. And they found that the moon was very seismically active, much more than they actually thought about. They thought, oh, the moon is dead. We don't really need to do this anymore. But oh my goodness, look at those results coming in. And some of these moonquakes got up to greater than magnitude 5. Now, if you're going to put a moon base up there, you don't want to put that at an epicenter, because on the moon, we have an earthquake. If you're unlucky, it lasts a minute. On the moon, maximum amplitude of a moonquake, 10 minutes. And it keeps on ringing like a bell, because there's no alteration of the minerals. There's no real dirt and clay minerals to sort of deaden that sound or that amplitude. So, and there's also experiments that Apollo put up there that are still active today. These are passive laser retroreflectors that we can shoot lasers to and get a reflection back, and the travel time tells us that the moon is disappearing from us. It's getting further away. Centimeters a year, one day it'll be gone. And then what are we going to do? Well, we won't have to worry about high tide. Look on the bright side. Some migratory habits may get a little screwed up, but will evolve or die. That's just the way it is. So when people say, well, they were all staged, right? We never went to the moon. Well, we can shoot lasers at stuff that humans put up there and get a return to show that, yes, there is something man-made up there, and humans put it there.
I'm going to step off the left now. It's one small step for man, one giant leap. So, I guess you want to do it again. Okay. Sorry, Mr. Worthy.
But what you got to know is NASA did stage the Apollo moon landings. Problem was, the astronauts were such professionals, they demanded they be staged on location. So yes, we went to the moon. I gave a talk in Kansas City a couple of weeks ago, and even after the talk, somebody says, I still don't believe we went to the moon like you say they did. I can't help that. We have the evidence to show that we did go, and we celebrate that this year. 50 years. 50 years. That's a long time. So, what happens if you accuse an Apollo astronaut on Apollo 11 that they staged the moon landings and they faked it?
You're the one who said you walked on the moon when you didn't. Calling the kettle black, if I ever thought of it. Saying I misrepresented myself. Away from me. You're a coward and a liar and a thief.
You notice he's punching up. Yeah, Buzz Aldrin's not a very tall fella, but he packs a punch. Now, this guy was a producer of the Fox expose, the fake moon landings. And he had been badgering him during a press conference, followed him outside, and then sued Buzz for assault and lost, which was good. But the issues when you have this, they never talk about the samples. What about the samples? You can't fake a moon rock that gives you a 3.8 billion year age. It's just impossible. If we could change radioactivity, we would have no nuclear waste problem in the world. So that would be good. So why did we go to the moon? Now this is before my time. Any ideas? Why did we go? Because it's there. Yeah, it's close. Well, let's go back. Go back in time. 4th of October 1957, Soviet Union launches the first ever satellite to orbit the Earth, going over the USA and looking down and beeping at it. And everybody freaks out. Then, 12th of April 1961, the first human goes into space to orbit the Earth, and it's not American, it is Russian. Sorry, Soviet Union. Got to get this right. And then some other things happened in the early 60s. We had the Bay of Pigs fiasco, and we had the Cuban Missile Crisis. So this was all compounding together, is that we really need to do something. So, 25th of May 1961, an address to Congress, President John F. Kennedy. He makes this speech to impassion Congress to fund going to the moon.
I therefore ask the Congress, above and beyond the increases I have earlier requested for space activities, to provide the funds which are needed to meet the following national goals. First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
So, this was a space race. We have to beat the Soviets. But USA was playing catch-up. A little bit behind on this one, and there's national pride at stake, and deflecting public opinion became something in the backfill because of what was going on in the Gulf of Mexico. So we had a space race that was going on, but we still needed a reason to go to the moon. And this one's not working. So he gave a speech again at Rice in September, and if you watch the video closely, you see people wearing suits in Rice Stadium in Houston in September, and they're perspiring just a little bit, maybe some expiring. Hopefully this one will work, because less than 7 years later, humans were going to land on the moon. So if this one works and we have sound, there's some things to look for there. 1201 alarm. And Jerry Griffin tells me you don't need to worry about a 1201 alarm, it just means the computer memory's full up. 1202 alarm means you've got to reboot the computer, wait for it to come back, and this is the navigation computer. So when you look at Neil Armstrong's heart rate as he's coming into land, let's just say it is non-trivial. His heart rate's, because he's landing on the moon for the first time, manual. No computer to guide you. Just take it in, get it done. Oh, went too far. And this one is not working either. When the volume is up, I know our computer guy is gone. Yep. But never mind. We will move on. Still. Anyway, as they come in, you also hear 60 seconds. That's Buzz Aldrin calling out time left of the fuel before they had to abort. And then you hear 30 seconds. And then maybe Neil Armstrong is saying, I need another spacesuit. I just filled this one, you know. But with about 20 seconds left, they touch down. And one of the most emotive things that I've ever heard is that, Houston, Tranquility Base here, the Eagle has landed. First time ever. Now, who's had their Apollo moment? Exactly. A lot of people in here have had no Apollo moment. Everybody deserves an Apollo moment. I'm sorry, but Google isn't cutting it. The iPhone isn't cutting it, even though Apollo's responsible for our iPhones. Thank you, Apollo. I'll come back to that one in a little bit. But there were lots of things that Apollo was responsible for. This one probably won't work either, but
everyone remembers Neil Armstrong's first steps on the moon and the words he spoke. Few remember the final speeches just 3.5 years later. The task of summing up the Apollo program fell to Gene Cernan as he stood on the surface of Earth's nearest neighbor.
As I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just let what I believe history will record that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. One, ignition. We're on our way, Houston. Vector good. I hear you have good product. 130 Houston, we're in the blind and we'll go.
So 47 years ago, and then we stopped. Why did we stop? Well, we'd won. Apollo 11, we'd won. So, okay, now what? Well, we'll do try to do 6 more, but we did 5 more. And Apollo 18, 19, and 20 are still on this planet. You go to Kennedy, Marshall Space Flight Center and Johnson Space Center, you can see the Saturn V's. We can't build a Saturn V anymore. That's a shame, because we need a big rocket if we're going to go back by 2024, and we don't have one. Space Launch System hasn't been tested yet. It was supposed to have flown in 2018. It is not. It has been postponed. So how are we going to get there? The other thing, the Vietnam War was getting expensive. Things were starting to heat up in Asia, and this was not good for the economy. So we needed to make some economies. Public had also lost interest. There was no live broadcast from Apollo 17, as far as I know. Well, this has become an old hat. It's like a shuttle launch. How many shuttle launches do we have? The ones most watched were the ones that weren't nominal. But these are the things that, how do we keep the public engaged? And then we have politics. And we're going to come back to look at this because, you know, Nixon was a Republican, Kennedy was a Democrat. And that's not my program. I want to leave my mark on this, in this nation, so I'm going to cut it. All right, good on you, Tricky Dicky. So, why else? Because space station was thought to be affordable, and Skylab was sent up there using some Saturn V parts to test out the idea of an orbiting space station around Earth. And Skylab, 1973-74, was put up there, and then it fell to Earth in 79 over parts of Australia. And in Western Australia, where my good lady wife is from, you can go to the Skylab Museum. It doesn't look as good as it does in that picture. But the other thing was Mars. And we keep hearing a lot about Mars. And boy, have I heard a lot about Mars. It's a red planet. And that's our next destination. And we had Vikings 1 and 2 that went there because humans were going to follow soon. Well, they haven't yet. So in 1989, George Bush Sr., Space Exploration Initiative, let's get back to the moon and on to Mars. And then we had a change, and Bush, being a Republican now, and Clinton, being the Democrat, got his own back and axed it. So what do? Well, we keep going to space station. That's where humans have been going ever since. So 2004, Bush Jr. gives us our vision for space exploration in response to the Columbia disaster. When the shuttle came in, one of the tiles was missing, and we all know what happened with that. So we extend human presence across the solar system, starting at the moon and going beyond. It's very grandiose, but it was an unfunded mandate. So presidential change, bring in a Democrat. So we're going to abandon the moon, but we're going to increase NASA funding by $6 billion over 5 years, which ended up being a negative $714 million cut over 5 years, which was, again, not good. But we're going to do a crewed asteroid mission in 2025, and then they realized there's no asteroid really close enough to do that. All right, well, then we're going to go bring an asteroid, put it in orbit around the moon, and send the astronauts to explore it. Good. Oh, we can't do that. Well, we're going to bring a 5-meter boulder, put it in orbit around the moon, and send the astronauts to explore it. We can't really do that either. Right, we're going to bring a 1-meter boulder. We're going to put it in orbit around the moon, and that's our human space exploration program beyond low Earth orbit. Why not just send them here? So look at the meteorites here, or the American Natural History Museum. I mean, they've got a lot of meteorites, like and asteroids. We could do that. So what we've seen then is when we have no direction, things start to get made up. The asteroid redirect mission comes from a water cooler discussion at one of the NASA centers, and I think there must have been alcohol involved in that water. But, okay, so how is this a long-term space exploration effort? And this is what we want to get into. If we are to fulfill the legacy of Apollo, we got to deal with this sort of stuff. So, where are we now? We go 11th of December 2017, President Trump signs Space Policy Directive 1, going back to the moon. You see Harrison Schmitt from Apollo 17 there on the right. We're going back to the moon to stay, basically. The difference this time, and this is, you could see this cycle, we go Bush Senior, Bush Junior, we're going back to the moon, onto Mars, going back to the moon, onto Mars. But the difference this time is that it's legislated that this policy involves the private sector. And this is my take-home message if I don't get to it. If we're going to have a sustainable human spaceflight program that we all pay for, we got to see some return on investment. We can't expect, because it will not be sustainable if the taxpayer has to keep shelling out for it every time. So the point here, the private sector creates jobs. So when my students at Notre Dame are graduating and I say to them, well, what are you going to do after the moon? They can come to me and say, I'm going to go work on the moon. Sorry, after Notre Dame. I'm going to go work on the moon. That's not science fiction. I really believe in my lifetime, I plan to live to 150. But I know in my lifetime, I think that's going to happen if we stay on this path. We're on a good path right now because we're starting to create jobs. They're not government jobs, they're private sector jobs. So what do we have? Well, we have a lunar gateway has been proposed, which is basically an orbiting mini space station around the moon, because NASA knows how to do that. We have one around the moon, around Earth right now. It's a staging post and a safe haven. It gives you global access around the moon, and it gives you an orbit which is just, to my thinking, weird. It doesn't get close to the moon. It takes you 6 days to go to the moon if you use the gateway. It takes you 3 days if you go direct. If it's a safe haven, if there's a solar flare, I do not want to be in a tin can orbiting the moon. I'd like to be in a lava tube, subterranean, on the moon. I got a bit more protection then. Problem we've got is this shoehorning asteroid redirect mission technology into a lunar program. Orion spacecraft was developed to dock with an asteroid, microgravity. Now we're putting it into a gravity well. It doesn't have the guts to be able to do it, so we end up with this weird-looking orbit around the moon. So we've got an issue with that, but we've made the investment, so we've got to use it. So the other take-home message is our space agency should be developing destination-agnostic technologies. Let's go anywhere. So when the next administration comes in and says, oh, we're going to Mars, okay. We've already started, already got this going. Yeah, when do you want to go? How many do you want to send? Makes sense to me, but I'm a geologist, not an engineer. So Gateway, you can see, is quite small, maximum of 4 crew. There's only 55 cubic meters of living space, so I hope they get along with each other. And the maximum amount of time they will be up there, at the beginning at least, is 30 days. It takes an SLS launch to get there, and we can only afford to launch one of those per year. So most of the time, this is going to be uncrewed. And it's going to be left up there doing experiments for whatever, because it can't do lunar science experiments. The orbit's all wrong. So I'm a little jaded about the Gateway. But this gives you, in a mock-up, you see the size difference between Space Station and Gateway. This is not meant to be a big infrastructure project. This is meant to be something that we can use to get to the surface, anywhere on the surface, and do it repeatedly. And I just hear now that this is to enable permanence, human permanence on the surface of the moon. I hope so, because it's what we're going to need. So, 26th of March, 2019. This is where we are now.
Just as the United States was the first nation to reach the moon in the 20th century, so too will we be the first nation to return astronauts to the moon in the 21st century. And I'm here on the President's behalf to tell the men and women of the Marshall Space Flight Center and the American people that at the direction of the President of the United States, it is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years. And let me be clear. The first woman and the next man on the moon will both be American astronauts, launched by American rockets from American soil. The President has directed NASA and Administrator Jim Bridenstine to accomplish this goal by any means necessary. In order to succeed, we must focus on the mission over the means. You must consider every available option and platform to meet our goals, including industry, government, and the entire American space enterprise. History is written by those who dare to dream big and do the impossible.
You have given us a charge today, and it is right on time. And I want to say thank you for that vision and the leadership. Our agency, NASA, is going to do everything in its power to meet that vision, to meet that deadline. And you have my full commitment to achieving that. Mr. Vice President, I can tell you, I am confident we can get to that first launch in 2020 for SLS and actually fly a crew capsule around the moon. We will be using the Gateway as a reusable command module to get boots on the moon as soon as possible. 2008 and 2009, NASA made important discoveries, hundreds of millions of tons of water ice on the poles of the moon. We want to be able to get to that polar region. We need a reusable command module. We need a command module that can, no kidding, maneuver around the moon. That's what the Gateway is all about.
America will once again astonish the world with the heights we reach, the wonders we achieve, and we will lead the world in human space exploration once again. Now let's get to work.
So, do we have another unfunded mandate? That's the next thing, because the goal is 5 years. 5 years. Goes quickly. The older I get, the quicker it goes. So don't blink too much. So it's lordy, the words are great, but my opinion, having met the NASA administrator a couple of times, I think he's the right person in that job because he's not a NASA insider, and he can, he's a very diplomatic man that gets stuff done. So in that, I'm hopeful, very hopeful. But we'll wait and see what the president's budget gets, because on behalf of the president, as the vice president was saying, by any means possible, get to the moon in 5 years, and now I hear but NASA just got a 10% cut. That's probably not going to work, actually. But we will see. But if you listen to that entire speech, it's the lunar South Pole. China announced today they want to put a base at the lunar, permanent base, humans, at the lunar South Pole. Looks like we may be in for another space race, because it is illegal for me to use a NASA grant to go to China to collaborate with a colleague there. I can go to jail for that. It's called the Wolf Amendment. NASA and anybody associated with NASA cannot have a bilateral collaboration with anybody in China. It's against the law. You can have a multilateral. So if I hold up my British passport instead of my American one, maybe they'll let me talk, because there's actually 3 of us in there. I'm a split personality. It's my Northern Indiana accent gives away. But the South Pole is interesting because it has peaks of near eternal light, and you can see the red and the whites there get up to about 70 to 80% of the year is in sunlight. So you don't have to survive very long in the cold of, the minus 200 Celsius lunar night. You just have to survive in the plus 120 Celsius, not Fahrenheit, lunar day. But you know what your thermal field is. But right next to those peaks of eternal light are the coldest places in the solar system, the permanently shadowed regions of impact craters, where you find, as the administrator said, hundreds of millions of tons of water ice, which is ice, really. Right? He's actually toned it down. He said billions of tons before, until we sent him the calculation and said, you may want to temper that a little bit. Until we get on the surface and see how deep that goes, let's just stick with millions of tons. So 100 million tons is, well, it's better. So we've got resources close, but they're down a 30-degree slope minimum and 40 Kelvin temperature. So what's that? Minus 233 Celsius that you've got to go work in. Let's send a robot, hopefully. So the other thing was by 2028 that this base would be established, a field station, as it's been called. And if we're going to do that, we've got to start thinking about the use of local resources. And this is, again, I think is something that is a game changer. What we know now from what we knew of Apollo is very different. We know that, well, it's a whole new moon up there compared to what we knew about during Apollo. So why should we go back to the moon? Well, I would say this. It's about return on investment. Let's bring the moon into our economic sphere of influence. Let's start leveraging the resources that are up there. Water, ice is rocket fuel. Liquid oxygen, liquid hydrogen. Let's start refueling the satellites around our own planet so that they can keep going and we don't have all the space junk in the way, or not as much. Maybe that's something we can do. Life support on the moon. Radiation protection, a meter-thick sheath of water around any capsule going to Mars will protect the astronauts from ionizing radiation. It's heavy. Get it from the moon. Gravity, well, is less on the moon. Stimulate technology development. Nobody, or very few people in Congress realize the economic impact that Apollo had on this country and the world. I held up my cell phone earlier on. My computer. This is the technology that was developed as a follow-on from what was needed and required for the Apollo program. My cell phone is by far greater and stronger than the Apollo 11 flight computer. We know that. So the technology that is part of the investment, that is a return to people down here, often gets overlooked because, oh, it's all that money. All that money goes to that. We need to keep it down here. We've got enough things to do down here. We don't need to do that. NASA's budget's 10%, right? How much of the domestic product is NASA's budget? Any idea? Yeah, well, 0.5. 0.5. You're knowledgeable. That normally I do this. Oh, it's 10%. 10%. It's a lot. It's a lot. It's really not. It's really not. But this is the type of investment that our space agency should be looking at. This is how you sell the program. If we do this, look at Apollo. The other thing, or two other things that I point out here. If you're going to send humans to Mars, they're going to be in microgravity for 6 months. Skeletons start to dissolve. What a great way to investigate curing osteoporosis and protecting astronauts as they go to the moon. This is something that I've not really thought about. Closed-loop life support is another thing for extended human space exploration. What about recycling down on this planet? The spin-offs from that are huge, considering we get more and more people on this planet, and the resources are dwindling. So this is something that's the investment in our future, not only to send humans beyond low Earth orbit, but also living down here a lot better and preserving what we have a lot better than we did before. So enabling NASA's budget to be an investment in our future is something that I think this new era of space exploration can do. The moon is this door that can be opened. It contains abundant resources. NASA's the key for determining if those resources are actually reserves, and we need a long-term plan that says permanence, human permanence on the moon to unlock that door and bring in the private sector. So NASA's budget can be used to stimulate that growth, to stimulate new jobs. And it's not the old sort of way of doing it, the old space, the Boeings. Oh, well, we'll just keep giving you money even though you can't meet deadlines. We're going to give you this much to do this. Can you do it for that? Yes. If you don't do it, there's going to be a penalty. That's just how we drive innovation. World leadership. America led the world to the moon in the 60s. It can lead the world back to the moon right now. But we need to learn from history. Competition does not give you a sustainable human space exploration program. Apollo has proved that. International Space Station has proved that cooperation is a lot better. You can see it there with regards to the longevity of space station. Cooperation rather than competition. I'm really worried when I hear, well, we're in a new space race with China. Well, okay, maybe we are, but if we go down that road, as soon as we win or lose, it's over. It's over. So we need to think more long-term than that. So it's cooperation, not competition. If we go with competition, it will give us a furious activity for a short number of years, and then it will be over. And there'll be nothing really long-term that we can show for it. So we really need to enable sustainable human space exploration, and I really think the resources that we now know are there are the key to doing that. But we need to go prospecting, geological prospecting. How much of those resources are actually there? Can I extract them, and can I extract them economically? Can I sell them? Who's going to create the market? Space agencies. So we need to be creative. We know that there's hundreds of millions of tons of water ice on the moon. So why do certain companies develop liquid oxygen, liquid methane engines? There's no methane on the moon. There's very little on Mars. But methane is easier to deal with than hydrogen in terms of cryogenics. So we need to commit to liquid oxygen, liquid hydrogen engines to drive the spacecraft, because water is the oil of the solar system. It's everywhere. Even on and in the moon that we thought was bone dry when the first samples came back. It's not. So The important thing here is to grow that cislunar economy. Start getting the return on investment, because we're now leveraging the inputs and the developments from the taxpayer out to industry. Been going on for years. We're doing it with low Earth orbit now. Expand that to the moon. Who knows, maybe even to Mars. That's in the future. But this is now very much in our present. So now the video's not working again, but that's okay. But what we're seeing here are some samples collected by Jack Schmitt from Apollo 17 at Shorty Crater. This was the orange glass, and you can see the 0.1 millimeter scale bar in those orange glass beads that form by fire fountaining a volcano into a vacuum. And you end up with these very spherical looking quenched glass beads. And these fire fountain eruptions happened a lot on the moon. And Apollo 15 and Apollo 17 brought back substantial amounts of this glass. And the thing is, they were collected in 1971 and 1972. It wasn't until 2008 we had the technology to analyze them and say, these contain water. What? 2008 was a paradigm shift for the moon. We thought, oh, maybe there's comets have hit the moon and that's what's given us the water ice at the poles. But now it's in the interior. It's coming up in volcanoes. And once we started to look for it, it was everywhere. I would say the moon is not wet. It's actually damp, but damp wouldn't fit in space, so I put wet. So we actually know that. And if we then go back and look at some of the orbital data, we can see that a lot of these deposits, the red areas, contain about 0.3 weight% water. And that's in the volcanic glass beads that came out. We also know from Lunar Prospector that flew in an orbital mission, flew in the late 90s, that there are hydrogen deposits, as I said, at the moon, Lunar Reconnaissance Orbiter. This century has actually verified that to be in and around these permanently shadowed craters. And then this paper came out last year that shows that there is significant water ice at the surface of some of these, because using the laser altimeter shooting into the permanently shadowed regions, they get a much brighter reflection than they do outside. Up to 30 weight% water ice at the surface of the moon. And then we have our first ground truth, which was the L-Cross mission in 2009, which was a piggyback on Lunar Reconnaissance Orbiter, and it impacted into one of these and then measured the plume that came up through the sunlight, and there was 5 to 6 weight% water in that particular plume. Water is there, it's a whole new moon, it is not dry, and water becomes a resource. But wait, there's more. We also know from the samples that came back, the moon doesn't have an atmosphere, doesn't have a magnetic field. It's hostile. You've got a lot of material coming in, micrometeorites, macrometeorites, radiation, and it gets implanted into this soil or regolith. And if you look at these mature regoliths, especially if they contain ilmenite, now ilmenite is a great mineral, iron titanium trioxide. You've learned chemistry tonight and mineralogy, and it's a sponge. It holds on to these implanted species. So if you take a piece of mature regolith brought back by Apollo, heat it in a vacuum, water will fall out of the bottom of the reaction vessel. There's not actually water in the regolith, there's the components to make water. So we have 3 ways, 3 different reservoirs for water on the moon. We can then use that if we can answer the question. Are these resources actually reserves? Can we extract it? Is it economic to extract it? Can we get mining companies to do it? Well, how much are you willing to buy the product? Where's the market? You've got to have a market force there, and you've also got to have an agency going up there prospecting, saying, we really need to find out how much is there. We need a resource prospecting campaign yesterday. Now, interestingly, 23rd of April, 2018, St. George's Day, but you all knew that. Maybe not. Jim Bridenstine was sworn in as the NASA administrator. On that very day, NASA canceled the only lunar surface resource prospecting mission that it was developing. I'm not saying there's a conspiracy there, but there could be a conspiracy there. So why would they do that? I have no idea. I have no idea. But this is not the NASA of the 1960s. So, last slide, take-home messages. Moon is not the end game, it's an enabling asset. We get to the moon, we bring the moon into our economic sphere of influence, we can go anywhere. We can use the moon as a test bed to develop the technologies to protect humans to go to Mars, long term. We can stimulate the industries to get involved in the cislunar economy. NASA's already got a commercial lunar payload services program where they contract private companies to deliver payloads to the lunar surface. This is a whole new world. You don't do it, you don't get paid. Simple as that. And there's 9 companies that have been contracted to do that. This is getting interesting now. It's the start. But human permanence on the moon will allow us to do so much more, and the resources become critical. We know about water. Water everywhere. But there are other things up there as well. I haven't got time to get into them. Some we don't have the technology to use, but they show an awful lot of promise. And with that, I'll take questions. Thank you very much.
Let's give him a round of applause. Thank you very much. All right, stay up there. This is the part where we grill you. You ready?
Yeah.
So the way Q&A works is I'll have a microphone that I'll pass around the room, and then our head of the Astronomy and Astrophysics Research Lab, Dr. Rachel Smith, will have the other microphone. She's going to be a lackey like me this afternoon. And we'll pass around the microphones to make sure that we can get to as many questions as we can. Please make sure that you give your question into the microphone. That way everyone in the room can hear. Wave at me if you want to get us started. The first one. I know you'll probably need a minute to think about everything that just happened because we got a lot in there. We got history of Apollo. Yeah. We got future. Yep. And what it's all going to mean. What does that all mean?
Are you allowed to ask a question?
I hope so. Okay. I know that you talked a lot about Apollo, but do you know why the Soviet space missions were never successful at landing anybody on the moon?
Their technology was not as far along as they led us to believe. And once, the way I understand it from talking to a few old timers from Russia, they basically, we'd lost. Why are we doing this? So they focused on robotics. And that's why you see, when you look at the robotic sample returns, they started in 1970, 74, and then 76. So that was what they were focusing on. They were bringing back the samples to the Soviet Union at that time. But after they started well, they then couldn't maintain that. And I don't know why. They were on a good path. We were way behind. The way I understand it. So.
Hello. Just a technical question. You mentioned the fire fountain volcanoes indicating there was water beneath the surface of the moon and it didn't come from incoming. Is there any thought whether all of the water ice that's in the bottom of the craters at the poles, is that thought to be from the inside of the moon?
That's a very good question. Since they found 2008, they found that. The question then became, well, where did this come from? We don't have a sample of the water ice in the permanently shadowed craters, so we can't analyze it to look at the composition to see from whence it came. We know what comets look like, so it was, comets hit the moon and it just got cold trapped in there because it's so cold, and it's just been built up over the millennia. But we really don't know. It could be because there's papers that just come out that said the moon used to have an atmosphere. When it was cooling down after its initial accretion, there was a big magma ocean, but there was a lot of boil off, and it had an atmosphere. Obviously, Since you had the hard shell and the crust formed, that went away. During the peak of the volcanism on the moon, doing about 3.6 to 3.8 billion, there was a tenuous atmosphere. And we actually found evidence for that when I had a student handpick those orange glass beads. They're all spheres, and all of a sudden he started to get Pellé's tears. Now, Pellé's tears are a teardrop shape, which means that it's fallen through something that is dragging the material around to form a tail. A volcanic bomb is the same way. It's got a blunt nose and a very slim tail because the viscous drag of the atmosphere. And it was remarkable. You know, oh, that's really neat. And I sat down and thought about it and went, that must have come down through an atmosphere. So it's a whole new moon out there. The samples collected in 1972 are still informing us because we have them here for future generations. So, more would be good. So we have three basic reservoirs of water. We've got it in the regolith from solar wind implantation of hydrogen. We've got it at water ice at the poles, and we've got it from these volcanic glasses from the interior.
The water that they can get from the ilmenite, is that thought to be the impact from?
That's just solar wind implanting hydrogen atoms in the regolith. And it reduces, it takes oxygen from the minerals. You get iron metal, you get titanium dioxide, and you get H2O.
So getting water ice from, or getting water from ilmenite is really getting...
Well, you get it from the regolith. It's just that if you have ilmenite in the regolith, it holds on to the hydrogen a lot better. As soon as you start scooping regolith, that hydrogen just sort of, it's just sucked to the surface. But ilmenite tends to, no, I'm holding on to you. So ilmenite is our friend in that respect.
So I'm curious. In your presentation, you put together, I think, a pretty good economic argument for getting us back to the moon. But you're a geologist, you're a scientist. What's the science argument for getting back? Like, the samples are 47 years old. We've been doing research and science with the samples. We're still making new discoveries. Yep. You just outlined a couple of them. Yep. But do we really need to go back and get more just for research?
Do we really need to go back and get more? Well, that's yes. All right, but why do we need to go back and get more is along the lines of we've had a lot of missions since 2000 that have orbited the moon. 2 have landed. One on the near side, which was the Chinese Chang'e 3, and one on the far side as Chang'e 4. China will be doing a robotic sample return in December this year. And they'll be bringing back their samples to China for the first time. So those orbital missions have showed us how little we know. They show us that the Apollo sample collection is not representative of what is on the surface of the moon. They've shown us that. We have no definitive sample from the far side. Lunar meteorites, they came from the moon, and that's about as good as we can get. But we have none of that. We have rock types that we know are on the surface now that we just don't have in the sample collection, that are going to change our way of understanding how the moon evolved and how it came to its present state, and even where it came from. We have no sample of that water ice. That's going to be a challenge. But where did that water come from? Was it part of the heavy bombardment that brought water to this planet? And we have our ocean planet, but we have our water ice cold traps on the moon. We don't know. So impact melts, impact bombardment history. That has implications for the origin of life on this planet. Yeah.
So you talked about the water ice being a source of fuel, the hydrogen being fuel for the spacecraft. I assume that's also the primary or the only source for breathing oxygen.
Oh, yeah.
And yet we talk about permanent stations on the moon, but there's limited, I mean, it's a limited pool. You said there's a lot of ice.
Well, we don't know how limited it is. We don't know. That's why we got to go prospecting.
So is that a concern that,
oh, yeah,
that there's just not enough to really sustain long-term existence on the moon?
You can make oxygen out of rocks. Just do electrolysis. So you melt the regolith, you do electrolysis, you get oxygen off and a bunch of other things, but that's been done. This is the low-hanging fruit. Oh, we got water, we electrolyze it. We got hydrogen, we can put it back into our feedstock. We can do that again. The closed loop life support, come back to that. The recycling aspect. You can scrub, you can take out the carbon, you can get oxygen back. Carbon is going to be good for fertilizing the regolith so you can grow crops to sustain, life up there. There's that closed loop life support comes, that's the payback to this planet that we haven't even thought of yet. But it's because we've got a common goal to do something. Why don't you use it to do that? That's where the ingenuity comes in, but it'll never happen. So, yeah.
Identified in those samples that would probably motivate a capitalistic.
Precious metals, or
yes,
great good friend of mine, Dennis Wing, and he wants to mine the regolith to extract meteorite group metals. I don't know whether that's going to wants to mine the regolith to get helium-3 out of it. Light on this. So if we look at is the nirvana of nuclear fusion. China just had a sustainable fusion reaction that lasted a few seconds at 12 million degrees. We don't have the technology to use it yet, but China is very interested in helium-3 and the moon. So you can see there, one maximum space shuttle cargo bay full of helium-3 will power the US for 1 year. Theoretically. But this is the nirvana because there are no toxic byproducts from this process that you get with nuclear fission. There's no investment going on in this country on nuclear fusion right now.
Okay. So I guess you sort of addressed the first part of my question. You mentioned how private industry is sort of the way forward for this. And the way I see it now, or the way I understand it, is governments are the only market for private industry. Mm-hmm. And I guess this sort of addresses that. But the second part of my question was, you mentioned all of the byproducts, the technology that we got from the Apollo mission. With private industry, that becomes their proprietary technology, mm-hmm. and we do not get the benefit of that necessarily.
But you forget who's going to be doing the technology development.
The private industry?
No, the government's going to be doing that. And then they'll lease it or leverage it. This is what we see going on. You look at, for example, take SpaceX. Mm-hmm. They have taken a technology and they have developed it. They've got the reusable lander. They are now showing government how to do things. Maybe that will happen. But when you're at a frontier, this is technology that the government developed to get satellites into low Earth orbit. The government no longer launches to low Earth orbit. It's private industry. That is now the private industry domain. Now, government's going to go to the moon. It's going to take private industry with it. It's going to set up infrastructure. It's going to set up technologies. It's going to lease that. Private industry takes it over, just as they've done with the low Earth orbit and GEO and HEO and all other EOs that you want to talk about. So, go to the moon. Private industry takes it over. Then we can go to Mars. We'll develop that. Let's bring Mars into our economic sphere of influence. So we take the low Earth orbit example. Extend that to the moon.
So in your vision, government still has a role in developing the technology,
yeah.
but private industry takes over in
right, and then takes it wherever.
Okay.
That's the way you're going to create the jobs. That's the return on your investment. And that's what makes me happy to say, why are we still paying Boeing for SLS? When it's missed deadlines, and they're still getting paid the same, and everybody's getting fat and happy. So, there's another, yeah.
Hi, you keep saying water ice. Is it water like we think of water, or is it the components that make up water? Yeah. And if it's water, is it, since there's no atmosphere up there anymore, mm-hmm. is it radioactive, and how would we get rid of the...
Not radioactive.
Okay.
It's not radioactive. I say water ice as opposed to carbon dioxide ice.
Oh, okay.
So I came over all sciencey, and I'm sorry, but it's ice, really. I say water ice to differentiate it, because you go to Mars and you look at the ice caps, they're both a mixture of CO2 ice and water ice. And in the summertime, you see them shrink, and then they stop shrinking because all the water is sublimated away, and it's just CO2 there, and the temperature isn't high enough to, sorry, all the CO2 is sublimated away, and then the water is not high enough to sublimate the water. So, yeah, but it's ice, as we would understand it on this planet.
So what does a group of people sitting around a science cafe do to get us back to the moon?
That's a good one. That's a good one. I've never been asked that question before. Never been in a science cafe before. I think that when you see, I get involved. And you see how much money is being spent on various things, and you start thinking, well, we should use that down here. Just think a bit deeper into what Apollo gave us. I think we got up to 5%, 6% of the budget during Apollo, but we were on a time crunch. We're on one now. I would say it was worth it because of the technology spin-offs and the rocks they brought back, or maybe the rocks they brought back and the technology spin-offs. But if you think of it a little different, NASA's budget is an investment in our future. I think we have the right person that is heading NASA. I think that civil service status should be taken away from NASA, because once you're a civil servant, you can't be fired. So you get fat and happy. Well, I'll just do this. I don't want to do anything else. I'm just cruising to retirement, and that's all good. I couldn't live with myself. But this is what happens. Shake it up a bit. Harrison Schmitt says, disband NASA and start again. Average age of people in NASA during Apollo was 28. It's not that now. Young folks are not constrained by thinking in the past. You learn from history and you say, well, how can I do better? All I get now from NASA engineers, no, we can't do that. Why can't you do that? Well, that's not the way we do things. Okay, now what is your job again? This is not the NASA of Apollo, unfortunately. But so maybe tell me what you can do. Oh, we can do Apollo. No, you can't, because you can't build a Saturn V. But it's time to think differently, and we need a new breed. These young folks. The future is bright, I think, because there's lots of opportunities to go out there and change the world. And don't let anybody tell you you can't. Yeah.
I have a question. So is there this idea, instead of this race with China or race with Russia or race with other countries, is there an ear for this idea, who are people making decisions for the economic benefit? Like, do you feel that these ideas are going to resonate, or they do now, or what's the future of these ideas?
Well, the future of these ideas is I keep pointing to history. All right? If you want to have a space race with China, then we won't have a sustainable human spaceflight program. Period. Because it's being done for the wrong reason. There's got to be a long-term goal. What is the long-term goal? Is it growing the economy? Is it to have human permanence on the moon? If so, why do we need human permanence on the moon? And I would posit it would teach us to live and work off planet, because one day we won't be able to live down here if we keep going the way we are. So we've got to start thinking ahead, develop those technologies up there to use down here to make life better down here. That's the reason for permanence on the moon, and to develop the cislunar economy.
And are there people listening to these ideas, like that's making changes now and funding these? I'm wondering, because they all sound like really good ideas that are sustainable potentially. I'm wondering how far they go to Washington. Do they listen to these ideas?
I've been to Washington and talked. Yeah. I went to an Achieving Mars workshop, and I'm a lunar guy. And they said, oh, because the nation is now going to the moon, we figured we'd throw you a bone and involve you. 80-page report from their Achieving Mars 4 workshop. And one of their findings, because I actually read it, was we see the moon in getting us to Mars. So that was my first slide when I gave my talk. I said, do you still believe this? Because if you do, I'm going home. Or how can we use the moon to go to Mars? Is that what we want to talk about? If you want to talk about that, I'll stay, but there's no point in me being here otherwise. And we've got this moon or Mars. It's no, it's moon and Mars. It's all the solar system. That's the long term. Why would we be limited by the moon? Why don't we go to Mars? Why don't we develop destination agnostic transportation systems? So we can do that. That becomes very important when you have a long-term future for the program and to drive that technology development. And I think a few people in Washington get it. Maybe not the right ones, but I think they get it. We'll see.
We'll do one more question.
I could take more if they want. I mean, it's...
So you mentioned using lava tubes as shelter from like solar storms. Mm-hmm. How prevalent are those on the surface of the moon as potential sites for bases?
I think there's over 30 of them been identified now. And the reason they've been identified is with the Lunar Reconnaissance Orbiter camera. This is an amazing instrument that is so many kilometers above the surface, and you get less than a meter per pixel resolution, and you can see these big skylights into these lava tubes. And you can see with the different shadow angles, you can see that they extend underneath. It's not just a pit. They actually extend out there. With the Grail mission, which was looking at variations in gravity, you can actually trace some of these lava tubes over the plains, over the lava plains on the lunar near side. So we know that they're quite extensive. Apollo 15 landed near what they called a rill. It was like a lava river, and they think that's a collapsed lava tube. So they're there, and they're quite thick. And quite frankly, when you've got a meteorite storm coming in, I don't want to be on the surface. Solar flare, yeah, I want to go underground. I certainly don't want to be in a tin can orbiting the moon in a near rectilinear halo orbit. So I think that's useful to look at. The downside is they're away from the poles and the water ice deposits. But some of them are in titanium or ilmenite-rich regolith. There's a trade-off. We've got options.
You changed my mind. We have more questions.
Are there any surprises you found from studying lunar rocks? Cool. The elements and everything. Are they like Earth?
Oh yeah, very much. Minerals are very much like Earth. The way what is different on the moon is the amount of titanium. This is another thing about, we didn't really go to the moon. And if you look at those documentaries, they never mention the samples. Right? We don't have basalt rocks like that on this planet. There is no composition like the Apollo 17 lavas that they brought back. We don't have anything like that on this planet. It's unique. And it's all to do with the way that the moon formed. And we got to, after the moon formed by a giant impact. A planetesimal hit the proto-Earth, and all that material that was thrown out coalesced around the moon, around the Earth, to form the moon. Then that moon, so much energy, either all of it or at least the top 500 kilometers was molten lava. And as that crystallized, it started what we call differentiate. So the high temperature minerals crystallize first, and they're dense and they sink. And then it builds up titanium in the residual liquid, and at the very end of it, for about 95%, a lot of titanium crystallized. And that's a dense mineral, and that sank through the other minerals. And it causes a lot of overturn, and that forms the source regions of these deposits, of these lava flows. And it's all to do with what we've learned from the samples. You can't get this from orbital data, what I call picture taking. You're just taking pictures and go, oh, pretty. Right? You have to get the samples and get down and dirty with the samples and figure out what's going on. And the more I look at those types of lavas, the more unique they are. and they become a great resource. Titanium is a great building material. We can make titanium on the moon pretty easy. It's not going to oxidize. There's no atmosphere. So that was, I'd say, one of the biggest surprises. The other one was finding water in the moon 36 years after the samples were collected. I mean, that's the gift that keeps on giving are samples, because NASA has done really well in curating those samples, keeping them out of the Earth's atmosphere and preserving them for next generation and the next generation. But they will run out eventually, so we probably need to get some more. And again, the more we look, the more we find. So,
with the rapid development in artificial intelligence, do you envision a time when AI robots would be manning trips to the moon?
I hope not. Probably. I mean, there are... Well, the last astronaut class had 18,000 applicants for 10 people. It captures the imagination. It captures to go where no man has gone before, or is that Star Trek? Yeah. But that's the thing. You know, I've got 6 granddaughters. I want to be alive for the first lady to go on the moon. All right, there are, I think it's 50-50 mix of a female to male in the current astronaut class. There's a great possibility for that. It's going to be brilliant. And it's, as I say, if we have artificial intelligence doing it all, it doesn't really capture the imagination that much, does it? So I'm just saying that I hope not. I hope we continue to be a spacefaring species, and hopefully a multi-world species.
So on that idea, if we go down the path of commercialization the way that you're envisioning, what are there international agreements to limit the worst of that? I mean, I don't want to look up and see an Alibaba logo or a Gazprom logo up on the moon, or Apple.
There we go. There we go. You're at frontier questions now. You want lawyers to get involved, don't you? Any lawyers in here? Anybody going to admit to being a lawyer in here? No.
Send them to the moon.
Yeah. No, and that is, in some circles, that is a great concern about the regulating this return to the moon. I think that if you over-regulate now, you kill it. And it may be sort of triaging, rather than trying to direct it, you just change course a little bit when things start happening. There's the Moon Treaty that's out there that the US didn't sign, and the Outer Space Treaty that the US did sign. And there are some languages in there that say that can be interpreted to mean that, well, we can go get the resources. If we get them, we use them. That's in the Outer Space Treaty. In the Moon Treaty, you can't use them. But we didn't sign it, so we don't acknowledge it. Neither did China. So, yeah.
I don't know if this is the correct way to say it, but is anyone in the United States actually working on helium-3 as a possible
Yes,
source?
University of Wisconsin.
Thank you.
Yeah. They've done a lot of work in the last 20 years on that. China has put much more investment into those technologies. In fact, their first orbital mission was to use a microwave radiometer to try and map out the amount of helium-3 in the regolith. I don't know whether they actually did that, because, they've created maps. I don't know how to interpret them, that's the issue. So, but they're working on it.
I have a non-technical question. It sounds like you've had some of the samples in your own lab.
Yep.
So, like, does Notre Dame get them all, or do other schools get it?
Oh, well, you have to apply for them. You write a proposal to get money to analyze them. Then you have to write a proposal to the CAPTEM, the curatorial allocation. Hold on a minute. No, that's not right. Curatorial and analysis planning team for extraterrestrial materials. There we go. All right, and you have to then request the samples and justify their use, especially if you're going to destroy them. I've destroyed a few. You have to dissolve them to analyze them to get the, but I don't destroy the entire sample. I take 50 milligrams. So it's, you then have to, then you are judged on the basis of your science, and if your science is lacking, you don't get the samples. You may have the money, but you don't have the samples. So so you have to make sure that you do request properly those samples. I used to chair the subcommittee that dealt with that, and so I know what's a bad proposal because I've written a few. So, but they're up there, but they are closely monitored. They're in Johnson Space Center. The samples are in a hurricane-proof vault that is 18 feet above the ground. So maybe I need to raise it, but it's watertight. If you get caught in there, there is an oxygen tank that you have to sit by the nozzle because you will suffocate otherwise. But that's where all the samples go when there's a hurricane event in Houston. And then 10% of the samples are kept out of Houston, in the middle of the country, on an Air Force base, in a climate-controlled vault, just in case. Just in case. They are national treasures. And if you are allocated those and you don't look after them, worst case scenario, best case scenario is you won't get any more. Worst case scenario, the FBI comes and takes you away. So it is quite strict, which is a good thing.
Did the hurricane threaten the samples when Houston got hit?
Oh, yeah, so they just followed protocol. They put them in the vault that was designed to withstand that. So everything was safe and sound. And they also put some of the other sample returns, the Genesis, Stardust missions, some of the meteorites, the Martian meteorites especially, went in there. So it's all, yeah, they take it seriously.
Those NASA folks are smart.
Yeah, some of them are.
Well, hey, I'm glad that we had a smart guy on stage tonight, too. Let's give him one more round of applause. Thanks for coming out. And hey, thanks to all of you for coming out to the Science Cafe tonight. I hope you enjoyed tonight's program, learned something new, got something to think about on your drive home. Stay safe out there, because I want you all to come back next Thursday night. It's going to be the first Thursday of the month, which means Science Trivia. Bring your team, compete for prizes right here in the Daily Planet Cafe. Yours truly will be your quiz master, so study up. And we'll see you for Science Trivia next Thursday. Good night, everybody.